So in the course of our handling some chemical data, some biological data, especially structures, might be meeting some terms, something like SDF, which means structural data format. We have PDB, protein data bank. These are formats in which we can download some chemicals or proteins. So because in doing bioinformatics, special drug design, you're going to need chemical structures, drug structures, natural products of phytochemical structures. Also be needing protein structures. There are 3D structures. So most times these things are downloaded in different formats. We have SDF format, especially for chemicals, SDF. We have a protein data bank. We have a PDB, which means protein data bank. And the in this protein data bank, when we download structures, when we download proteins for our studies, we're going to be meeting PDB format, which is a format that you download compound. So not compound, a format that you can download proteins in. We also have a smileless or smiles, whatever you call it. This deal with structures, drug structures, or chemical structures. There's a format, a line representation of a chemical structure showing carbon, nitrogen, oxygen, you know, and some atoms, depending, uh, but not hydrogen, because the hydrogen is obvious. When you write a carbon, so it's obvious that hydrogen is surrounding it, depending on the saturation and the number of substrate atoms around the carbon. We also have a a faster format. Faster format is also a line representation it's a representation of amino acid components of a protein, showing only the an alphabetic representation. So each amino acid has a single alphabet representation. I mean, it has an alphabet with which you can represent each amino acid. So if I'm told to write out amino acid sequence, instead of writing the amino acid in their full name, I can decide to use an alphabet to represent these amino acid sequences. And these alphabets are standards. So which I will show you in the next slide. You see the standard alphabet for representing each amino acid. So we have a PDB-QT format also. By the time we start doing molecular docking, you start seeing this format. We have amino acids. You should know very well about the amino acid, the 20 amino acids mainly. And the active sites. The active sites, when we talk about active sites, we're talking about a portion in a protein or in a protein. Well, if you see a protein structure, a protein 3D structure, it can be so large, but irrespective of the size, there is a point on that protein where a drug need to bind to elicit pharmacological activity. Depending on the pharmacological activity being studied, you see a door now. A door can be so big, you can regard some parts of the door as an active site. Where you put key to open the door, you can call it an active site, because without that place you cannot open the door. You need the key. You need to put a key in that hole. Just see that key you are putting in that hole as the ligand, and then that hole where you put it on that door as the active site of the protein on that door. When I say ligand, I mean drug chemical, or drug compounds, or phytochemical compounds. The compounds of interest, we can call it ligands. For protein, we can call our protein receptors. So when we talk about proteins and the active sites with showing you images, it will be clear you understand it more better. But just know that the active sites are points where drug need to bind to be able to elicit a pharmacological or even toxicological activity or toxicological effects. So these are the amino acids. You can see the letters representing each of them. You can see for alanine, it's not always the first letter. Eh. Because if you it's not always the first letter, because if you look, there are some, if you look at the first one, alanine is A. The other ones also that started with A also, but you can see arginine is R, asparagine is N. You can see aspartic acid is G. So these are standard representations. So if I represent amino acid using this one letter, is what we call FASTA sequence. So we have databases. We have chemical databases. I told you about zinc, PubChem, African Natural Product Database. We have coconut. It doesn't mean the coconut we eat. So it's collection of open natural products. You can download compounds from all these databases. They are free, except for now. For those of us in this part of the world, this zinc is not free. This zinc is not free, but others are free. This African Natural Product Database has about 6,511 compounds, 515 compounds actually. And then this Corona database, when you go and look at it, it has more than 400,000, about 400 and something thousand compounds, natural compounds. So we have a biological databases. Sorry, these are actually biological databases, not chemical databases. For this page, these are biological databases. The biological databases, the most common ones, there are so many of them, but for the sake of our training, we're going to be seeing PDB, Protein Data Bank, we're going to be seeing Uniproct. Uh, these both are biological databases, not chemical databases. So we're going to see more of this. So some applications will be needing in the process, like Pymol. Going to be needing Pymol. Pymol use it to edit, visualize protein, edit protein. Uh, By the time we go into training, you see so many things we can do with Pymol. We also be needing Autodoc tool that we use to prepare uh, ligands and prepare our proteins. For the ligand, if you have few ligands, you can prepare it with Autodoc, because you have to use your mouse, click, click, click in the preparation. But if you have thousands of compounds, you cannot be doing them manually now, preparing them manually. There are some other means which you can prepare. There are some automated means of preparing ligands. We get to that. It's gradually, gradually we get to that. So these are the small, small things I think you should be aware of before we now enter. Protein data bank and UniProt are biological databases. So have this information. So as you go on with the hands-on, it'll be easier for you to follow and understand.